Alright, so here's a video of our first thrust test using both motors. Do a quick walkthrough of the testing setup. So this is a circuit that I put together. I'll just unplug that. We have a Arduino Pro Mini that's basically treating the brushless controllers as servos. So it's just sending pulses out via, let's see if that focuses right, via those two digital pins going to that ribbon cable. That ribbon cable carries servo power and signal down the thrust arm and up to each one of the electronic speed controllers, like so. Those are then wired into the motors. I soldered and shrinked everything and got it all kind of safe. You can see the big yellow thick wires. Those are power for the ESCs, and those both go to this 360 watt power supply I picked up. You know, I'm probably gonna exceed its limit, but I also have this bench supply that I built pretty recently that is having some problems. I think kind of figured it would have enough. I might be getting like a ground loop or something, so they're not isolated power supplies, and I was getting some weird power stuff going on. So I'm just not going to use that supply. I'm just going to try using using this one and see how much thrust we can get if this thing goes into thermal overload. Whatever, that's fine. I'm going to be powering the Arduino circuit using this you know, isolated power supply, so I shouldn't have any issues there. Yeah, and all the code is available in the Dropbox repository under Thrust Tester Program. Looking at this program a little bit more, I have one of these handy Adafruit OLED displays. So let me power this up. I spent too much time last night putting directions on the display, so we'll see what it does. GimbalBot. Safety glasses are on, very important. And we have that button right there. The capacitor on the button is just a debounce, because you know, that's how it works. And potentiometer is this little guy. So, for your safety, the system will only start if the RPM is at 0. Thanks. Good luck. Excellent. So this power supply right now is not on. You know, I just unplug it from my little power strip guy. So you can see I made this little kind of quick and dirty HMI. It's got this button so I can go from stop to running. Then if I twist this potentiometer, I can adjust the RPM. Based on the kV rating of the motor at 12 volts, I should be able to top out at 15,000 RPM. I don't have a tachometer of any kind on the motors right now. That's something I'm actually thinking about doing. Just because I'm curious to see what they're actually spinning at. So this is really just kind of a relative thing. But you can see I can hit emergency stop, but then RPMs are up, so it won't let me start again until I do that. All right, so this system is on. You can see I got it powered up. So I'm sending control signals out to the ESCs, but I'm not actually sending them the power they need to run. So why don't we? I haven't actually tried it with two propellers yet, so why don't we power it on and give it a try. Let's get our scale. This is like a $10 scale that I bought as part of a Pinewood Derby competition, because the corporate world apparently does that. Set it to grams, so you can see I got my my C-clamp there, and I've already tared it out, so it's reading 0. I'm gonna move I have a ring light on right now. I'm gonna turn it off because it's giving us some glare. All right, well, let's plug in the power supply, and the motors are going to start twitching. See if they do it. Yep, I don't know if you could see that. They twitch a little bit. That's fine. Put this to run mode. You're going to hear some different beeps. That's the motor's arming. Let's see what happens. So I'm going to start advancing the potentiometer very slightly. Very low. I actually ran this earlier and ripped a hole in my curtain because it's a lot of air that's moving. You can see the wrapping paper from a year ago that we haven't put away yet is also moving. And right now we're at 160 grams of thrust. I really hope that this video is registering my voice because this is kind of loud. So let's look over here. This says we're only at 700 RPM. Again, that's probably not accurate. So let's crank that up to 1400 RPM. Things are getting more interesting. More thrust. Pretty much pegged right now. Looks like I'm getting about 1.5 kilograms of thrust at maximum. You can see the motors are sinking. I don't have a lot of lateral stability on this frame, but nothing's broken yet, which is good. And it's really blowing a lot of things around in my room. So I got a fan blowing there. All right, so 1,450 grams of thrust. Yeah, we'll see what that does. It's going to constrain our weight a little bit, but I think that's a target that we can stay within and keep our thrust to weight ratio below or well above 1.